Hi, I'm Mahima Pushkarna, and with me today is Andrew Zaldivar. We're excited to present our paper, written with co-author Oddur Kjartansson, on data cards, purposeful and transparent dataset documentation for responsible AI. But before we begin, we would like to acknowledge that this work is the result of the participation and input of several people over multiple years, whom we thank for their invaluable contributions. Because of the diversity of people with whom we engaged, we're able to draw from multiple perspectives to our framing and approach. We've distilled the nuances and insights from translating a research idea into a transparency artifact that supports production scale practices into objectives, principles, frameworks, and a template that are available in our paper.
We believe that data cards, along with their scaffolding frameworks, are an early stride in the complex and nebulous space of transparency. We invite you to share with us your critical perspective, ideas, and challenges that we may have missed.
We've observed a virtuous cycle in transparency. Things that are transparent are easier to understand, and things that are easier to understand are perceived to be more transparent. But we've also seen that people across a data set or a model's life cycle often don't have a comparable or accurate understanding of the systems they're making decisions about. As our data sets and models become increasingly entangled, our ability to pass this relationship between them is a critical first step towards fairer socio-technical outcomes.
Attempts at introducing standardized, practical, and sustainable mechanisms for transparency that can create value at scale are often met with limited success, both in research and production contexts. This is reflective of real-world constraints of the diversity of goals, workflows, and backgrounds of individual stakeholders who participate in the life cycles of datasets and AI systems. Existing approaches seek to attain greater visibility into datasets and machine learning models by exposing source code, contribution trails, introducing machine learning-driven data analysis methods, and diverse oversights. While these efforts and several others have made fundamental contributions in AI and dataset transparency standards, we find that there is still a gulf between incentives for transparency and its potential value. The reality is that data and model creation is a chaotic and unstructured space, not as programmatic as technical documentation alone suggests. In our work, we found participants across multiple workshops often describe transparency as subjective, audience-specific, and contextual. Of note, we find that approaches to transparency that are limited to simply reporting details quickly become insufficient for practical uses. We find the need to systematically identify both the kind of information that decision makers can use in decisions and the processes and guidance needed to acquire this information. In essence, we need to frame transparency in terms of systems, intended audiences, and their goals. So, we frame our definition of transparency as a clear, easily understandable, and plain language explanation of what something is, what it does, and why it does that. This definition emphasizes the domain agnostic and inclusive prerogative of transparency artifacts.
To that end, we introduced data cards. A data card contains a structured collection of summaries that have been gathered over the life cycle of a dataset about both observable and unobservable aspects needed for decisions in organizational and practice-oriented contexts. We offer a design structure such that readers of different proficiencies can easily create a mental model of the dataset being described. The goal is not just to help readers determine use case fit, but to help them determine if I do this, then that happens, which in turn allows them to make decisions about data usage with greater comfort and confidence while building or evaluating machine learning models, be it for product, policy, or research use. What you see here is a data card that was created using an earlier version of our templates. It describes the translated Wikipedia biographies dataset, an evaluation dataset that was explicitly designed to combat poor gender accuracy in machine translation. It distills a dataset with multi-gender representation from 57 countries that touch every continent on the planet into 3 pages. But it also speaks to why non-binary individuals have not been represented in this data set. Beyond just technical documentation, data cards make intangible information visible, surfacing important factors for decision making. Data cards provide explanations of processes and rationales that shape the data but cannot be inferred from the data set directly, such as provenance, representation, usage, and fairness related analyses. These are critical information that are harder to express simplistically, they're harder to capture with structure, and they're often lost to time and people. For data cards to truly act as boundary objects, they need to be easily available in accessible formats at key steps of a user journey. In effect, these are a single central source of truth that help individuals of different backgrounds find both the information that they're looking for and information they didn't know that they needed and could affect their decisions.
To get to where we are today, we worked with 12 teams in a large technology company to create 22 data cards that describe image, language, tabular, video, audio, and relational data sets in production settings. This allowed us to design data cards for a topology of cross-functional stakeholders who engage in decision-making on the basis of a single transparency artifact. In this topology, we have producers, the upstream creators of data sets and documentation, responsible for the data collection, launch, and maintenance. Our next group comprises of agents, stakeholders who read transparency reports and possess the agency to either directly use or determine how others might use the described datasets. And finally, we have users, a group that describes the individuals and representatives who interact with products that rely on models trained on a dataset. However, users in this context require a significantly different set of explanations grounded within product experiences. But regardless of who the audience is, all data cards need to meet 4 objectives. First, they need to be consistent so that they can be compared, regardless of dataset modality. Claims need to be verifiable within the context of use. Second, they also need to be comprehensible, created concurrently with the dataset. This ensures accuracy in content and source. Notably, this requires repeatable, standardized methods that can be adopted and applied across datasets. Third, data cards need to be intelligible and concise. They need to maintain a fine balance between how much information it contains and the quality of that information. That way, data cards can communicate to the least proficient reader while simultaneously allowing an advanced reader to find more details. Lastly, data cards need to embrace uncertainty. Knowing about unknowns is useful information for deciding how and when to use datasets, as well as building trust. Including clear descriptions and justifications in a data card can mitigate risks and reveal opportunities for fairer, more equitable models.
In principle, we've designed data cards for practical applications. So they're intentionally very flexible, modular, and extensible. They're accessible, but importantly, they're content agnostic. Part of the reason was to provide a cohesive and useful experience for producers and readers, as well as the platforms on which data cards would be integrated. The fundamental display unit of a data card is a block. This contains a title, a question, some space for additional instructions or descriptions for the question, and an input space for answers. Blocks are arranged thematically or hierarchically on a grid, so we can enable an overview first, zoom and filter details on demand presentation of the dataset's documentation, so that readers can establish relationships both within and across sections. Blocks with related questions are organized into rows, and then rows are stacked to create sections using meaningful and descriptive titles. Since each row is thematically self-contained, readers can effectively navigate multiple facets of a dataset within a single data card. Answers increase both in detail and specificity across columns in the direction of the language in which the data card is written, allowing readers to find information at the appropriate fidelity suitable for their tasks and decisions. Second, we saw more robust documentation when we provided assistive structures for open-ended answers, predetermined responses for multiple choice questions, and demonstrative examples where responses could be complex. These structures were often modeled after completed data cards and were found to be incredibly useful for setting expectations about consistency, clarity, and the granularity that was expected in a data card.
Our design of structuring questions within rows mimics the way we humans typically probe complex systems, by asking meaningful follow-up questions at different levels of abstraction. We call this approach scopes, a metaphor to focus and frame questions and reveal obvious, non-obvious, visible, and invisible aspects of datasets. At the highest levels, we capture lexical attributes needed for discovery and use in large repositories. We call this telescopes. Periscopic questions facilitate quick assessment of suitability and relevance of the dataset, essential for simple decision-making. And microscopic questions were most challenging to answer since they require articulating implicit knowledge. Together, Telescopes, periscopes, and microscopes layer useful details such that numerous readers can navigate without losing sight of the bigger picture. Now, structure without content is an empty shell. So from the same 22 data cards that we co-created with 12 teams earlier on, we consolidated questions into a canonical template and identified 31 different themes that characterize transparency in dataset documentation, which we later verified with an internal MaxDiff survey. However, not all themes are uniformly relevant to all datasets, nor equally applicable even within a dataset. We also found that not everyone on a dataset team can report on all themes equally. So, we created Often, a knowledge acquisition framework for systematically considering how topics promulgate across all parts of a data card. Often enables a consistent and repeatable approach to add or tailor these themes to new datasets without compromising the data card's user centricity nor transparency.
Notably, we extend a dataset lifecycle in this framework to include both the outcomes of practical uses of a dataset and prototypical examples necessary for deeper probing. Inductively often supports activities with agents to formulate questions about datasets and related models that are critical for decision making. Deductively often can be used to assess if a data card accurately represents that dataset, resulting in formative effects on both documentation and the dataset. For example, early stage datasets will be more skewed towards origins or factuals, whereas more mature datasets are expected to be skewed towards experience. We found that data cards with a clear underlying Often structure are easy to expand and update. So data cards can grow over time to include topics that are typically excluded from documentation, such as feedback from downstream agents, notable differences across versions, and ad hoc audits or investigations from producers and agents. So dimensions are directional pedagogic vectors that describe the data card's usefulness to the agent. We identified over 98 unique dimensions, and through the process of criteria-based elimination and clustering, we finally arrived at a set of 5 dimensions that encompass transparency and can be deduced from documentation.
Unsurprisingly, when we instantiated a review program for data cards, we found that structuring feedback along these dimensions made it easier for data card creators to tangibly improve their documentation. In some cases, feedback from expert reviewers revealed specific opportunities to enhance the datasets themselves.
Our paper documents 2 case studies that provide insight into how our objectives, principles, templates, and frameworks all come together to add transparency to datasets in real-world research contexts. We found that data cards are able to hold a common identity when they're used by different stakeholders in decision-making. We also saw diverse teams use these dimensions, constructs, and vocabularies in ways that were meaningful to their own communities of practice. However, we also learned that creating data cards as a last step in the dataset lifecycle significantly increases the perception of work involved. Creating data cards alongside the dataset, on the other hand, enables the inclusion of multiple perspectives: engineering, research, user experience, legal, and ethical perspectives that can improve both documentation and dataset quality. Lastly, it sets up mechanisms for early auditing and feedback. This gives data teams the time and space that they need to consider responsible AI practices from both experts and non-experts that can affect data design and analysis, and in the long run, product outcomes.
Through our in-depth frameworks, detailed qualitative and anecdotal evidence for the efficacy of data cards through 2 case studies, we feel that our underlying approaches advances the state of the art of transparency and AI by 1, surfacing transparency principles and establishing objectives for transparency, 2, expanding existing paradigms on the constitution of dataset documentation, and 3, by enabling the human-centered design of frameworks for structuring, adapting, expanding, and evaluating data cards. We need more participatory approaches that engage diverse, non-traditional stakeholders early into the dataset and data card development process.
We also need to see how our frameworks and findings translate into different domains and industries, organizations of different scales, and datasets that describe globally diverse and unique cultures. We believe that data cards could enable future industry standards of transparency and documentation, standards that emphasize the ethical consideration of a dataset in ways that can be practically acted upon.
Thank you.